Okay, so today we're going to learn how to write a line equation given points and also given a slope and a point and also given a line and a point. And the reason this is going to be useful is in the future we're going to learn how to find these line equations but with higher degree things like quadratics or cubics or quintic functions. Like the higher the polynomial function, it actually works very similar to how you do this with linear things. So we're going to work on this today. When I have 2 points and I want to write a line, the first thing that I think about is what we learned yesterday, what a line equation looks like. And it looks like y equals mx plus b. And it will look like that every single time. And so what we know from this equation is we know m is our slope and we know b is our y-intercept. So those are the two things that we have to find, is we have to find our slope and our y-intercept. And so what I know about finding slope is I know I can find slope by this formula, y1 minus y2 over x1 minus x2. And when we're finding slope with that, it should make some kind of sense because slope is rise over run. So this is how much it kind of goes up, like this is the difference or how far apart these two things are. Same with your x's. It's your run, so it's how far apart these two x's are. And so when we look at this, we're going to look and see, oh, y1 is 2 and y2 is negative 4. So we're going to subtract these two things. So 2 minus negative 4 over, and now we're going to look at our x's, and our x's are negative 2 and negative 5, so negative 2 minus a negative 5. And we're going to get that to be, well, that's 6 over 3. And we know that 6 over 3 would reduce to just be 2. So my slope for this thing is equal to 2. Now we're going to use that. So we just spent all that time writing down that to use that information. So we're actually going to move this over here. I'll zoom out just a little bit so I have some room. And we're going to rewrite what we had before, which is y equals mx plus b. But instead of writing m down, we're going to write what we found, which is 2. So we're going to say y equals 2x plus b. Now what I have to do is I have to find my y-intercept. And the issue that we have right now is that none of this information tells us our y-intercept. This information will tell us some nice things though. It will give me an x and it will give me a y. And that is two things that we also have as missing information here. Is our y's and our x's. This is also an x and this is also y. You could use either of the 2 points. Normally I use the first point just because it makes it a little bit easier. And so now when we do this, all we're going to do is replace your y with what you know. And so we know our y is 2, so I'm going to write that down. And then over here I'm going to replace my x with what I know, which is negative 2. Well, now we only have one variable. So we can solve this pretty easily. So we'll have 2 equals negative 4 plus b. We'll add 4 to the other side, and we'll get that b is equal to 6. Well, now I know that b is 6, and I know that my slope is 2. So I now have my line equation. My whole line equation is y equals 2x plus 6. And that's my answer. When you're doing problems that are like this, the biggest thing to keep in mind is this is the blank slate that we don't know, and we're going to use this information to find all the answers. Let's try another problem. Now we're given this information when we want to write a line equation. So what I'm given is I have a line that has a slope of 3, and it goes through the point 4, negative 5. And so we're going to write our line equation again. This time we don't have to do all that work to find the slope. We already have it. It's 3. Say y equals 3. And this time I don't have 2 points to choose between, so I'm just going to use this point over here. I know that's x and I know that's y. So again, over here, instead of writing y down, I'm going to write 5. And instead of writing x down, I'm going to write -4. And then I'm going to solve for b. So I'm going to get 5 equals -12 plus b. I'm going to add 12 to both sides. And I'm going to get that b is equal to 17. So again, my whole line equation, we don't want to just leave this as our final answer. We want to write a line equation. We wanted it to look something like this. So our line equation would be y equals 3x plus 17. Let's try one more. Now we want it to be parallel to y equals 2x plus 4 and go through the point 2, 7. Now this time it's going to be again a little bit different, but it's going to be similar. We again want a line equation, which would be y equals mx plus b. This time I know my slope right off the bat, because if it's parallel, that means the lines are like this. So if this slope is 2/1, this slope is 2/1. So I know what m is already. It's 2. So I'm going to have y equals 2x plus, and you have to put b again. Now some people think, oh no, I have a b value, Mr. Rose, it's right here. I want you to think about it. If this line has the same slope and the same y-intercept, that doesn't mean the lines are parallel. It means you wrote the same line twice. So we did not get the right line. So make sure that when you do these kind of problems, you do not make the b values the same. We still have to find it. Now, when we see this over here, we're going to write this as x and write this as y. And we're going to plug that in. So I'm going to have 7 equals 2 times 2 plus b. Or 7 equals 4 plus b. Or when I minus 4, I'm going to get that b is equal to 3. So that is going to be my b value. And then I can, because I knew my slope from before, I can write this as y equals 2x plus 3. And I said this was going to be the last example, but I need to do one more where we deal with perpendicular lines. So let's do one more example with perpendicular lines. If you remember from before, a perpendicular line is a little bit more unique than another kind of line. So a perpendicular line is literally the exact opposite. So it like makes this right angle. When we say the exact opposite, it means that it's an opposite reciprocal, meaning that not only do we flip the fraction, we also flip the sign. So this slope was -1/3. The slope for our equation is going to be 3/1, and see how that was negative? This one is opposite again, so it's positive. And see how our fraction was 1/3? Our new one is 3/1. It flips everything. Plus b. And again, we put plus b because we don't want this equation to be the exact same. Now, I mean, we have switched the slopes, so they wouldn't be the exact same, but we don't know if they intersect at 2. So we're going to use this to help us out. Again, this is my x, this is my y. So over here, instead of writing y, we're going to write 1. And over here, instead of writing x, we're going to write 2. Now I'm going to get 1 equals 6 plus b, minus 6, and b is equal to -5. So my equation is y equals 3/1 x minus 5. It's important when you do all of these problems that you kind of try to keep everything in a similar order. And really what we're doing here is we're doing a whole bunch of substitution, right? We're first trying to find what your m value is and substituting that in. Then we're going to try to find what b is, and we'll substitute a point in for x and y. And again, the higher functions will work similar. Hopefully this helps. If you have any questions, please let me know. Thanks.